here is related to the UrbanFlood project, which is done within the 7th framework program. And just a few words about myself. I'm involved in a research team. We mainly research on distributed computing environments, so we are not directly involved in spatial data infrastructures, at least not before this project. So a good part of my presentation is therefore experiences, lessons, and some opinions that we have based on this experience with Inspire and spatial data. So I'm going to present the motivation for our work, then briefly about the project UrbanFlood itself, and the core technology of this project, which we call the Common Information Space. Then I will explain how early warning systems can be built on top of spatial data infrastructure, basically. And finally, I will move to the conclusions, which is a good few slides regarding aspects such as Inspire itself, OGC standards, availability of data, and other aspects as well. So from early warning systems against natural disasters are the subject of project UrbanFlood. And from our point of view, we are the IT people in the project. Such systems are complex distributed systems, basically, that consume and produce spatial data, actually. But actually, they have to compose different data and services into a complex scenarios, complex workflows, basically. And that's the UrbanFlood project goal, to simplify this complexity, to facilitate creating early warning systems, and to provide kind of reusable building blocks for early warning systems. We provide a blueprint, let's say for a flooding early warning system, and you can take the blueprint and deploy it at your location and have a new early warning system. So the UrbanFlood platform is meant to be generic, but we validate it for flooding, for flood early warning system. And so what we do, we monitor dikes. We monitor dikes through sensors deployed in the dikes, and then we analyze in real time. We analyze the sensor data in the UrbanFlood platform to detect emergency situations. I will explain details on my next slides. So what is the challenge for such early warning systems? Well, the challenge is that we deal with diverse distributed resources. For example, if we are to perform a simple simulation of a flooding, which we do, it is only one service that we have in the flood early warning system. For this, well, we have dikes with sensors, and we have sensor data. That's one set of resources. Then we have an application that implements some simulation model, and we have some HPC resources that are to be capable to run this compute-intensive application. And then we also need some other data sets like terrain elevation in order to perform the simulation. And these resources need to be brought together and composed and orchestrated into a complex scenario. So the approach we take is this. We expose the resources as services, and then we provide a core system of UrbanFlood. We call it the Common Information Space. And the Common Information Space, basically, it allows one to implement the business logic, let me say, of an early warning system, and then it allows to host early warning system at runtime. And also what we do, we leverage clouds. So instead of utilizing local HPC resources, we actually leverage compute clouds, but not just to store data, to do also compute-intensive calculations. And that's the whole system in a simplified architecture of it, basically. So we have the various resources that I was talking about, like dikes, datasets, and the applications for analysis. And the applications we actually virtualize and make appliances that can be deployed on demand in the cloud. And all these are accessible through a service interface, so they can be invoked, accessed, and managed through the network. On top of basic services, we can create more complex composite services as well. And finally, we bring together a number of services, provide additional business logic, business rules, and things like that, configurations, etc. And we have running early warning systems. And all this is hosted in the common information space, which I don't have time to discuss details about it. So the scenario that we have in project UrbanFlood is a flood early warning system. In this scenario, basically, we have a cascade of models. So we monitor the dikes online, section of dikes online. And the first level of analysis is through artificial intelligence. The AI can discover anomaly in sensor signals, like spikes, strange behavior in sensor signals. And that's the first alert level, let's say. If we decide that further analysis is required, then we can calculate, for example, dike stability calculation. We also have model for this, dike stability depending on the current environment situation and readings from sensors as well. If dike stability gives some kind of negative result, then we can move to further analysis and even do simulations of inundation should the dike be breached, or simulations of evacuation behavior or prediction of life loss. And this scenario is basically as a system, just to show you this, is realized basically as a set of services which are connected to a common bus and basically exchange information. And there is some business logic on top of them in order to orchestrate. There's some decision making in large part made by humans, but also automatically. So I have this, we have set up this simple example of a flood simulation service based on OGC implementations of OGC services, spatial data, and we have set up the flood simulation service as a WPS service, basically. And this service, basically, it takes as inputs the elevation data of the terrain to be flooded in simulation only, thankfully, the properties of the dike, the breach location in the dike, and the water levels, the water that flows through the dike at time series data, basically. And output of the service is basically the inundation data, also time series, which shows in time steps how the area is going to be flooded. And the computational backend is, as I said, deployed on the cloud, and we rely on computational models from our partner in the project, a British company, HR Wallingford. We thought that these data sets that are needed, well, they should be also available as standard services. We couldn't find such services. So we set up our own services. We implemented our own services. For the terrain elevation, a coverage service, that's the input data, and graphically it looks like this. A piece of data, that's a science park in Amsterdam. And we also, the output inundation data, we also publish as a service, as a coverage. So that then this simulated coverage data can be reused in some further analysis. For example, in the evacuation simulation, this data is required. And data about dikes could also be available as feature service, but we have not implemented this one. So the inundation data is graphically basically something like that. You can put it on the map, but you can also download, of course, the data itself for processing, which we do, because we pass this data to the next simulation. And that's my last slide before the conclusions. So let me just make this one comment that I learned, based on my first experience in Inspire and also being at this conference, that such systems in general are not yet possible to be built because we don't have yet this harmonized spatial data infrastructure. But on the other hand, I think that early warning system is a good example of a system, of a complex system that can be built once we have this SDI. So let me just share a few comments why we think that such system cannot be deployed in general in Europe, for example, right now, apart from the fact that we don't have sensors everywhere. First, some thoughts about Inspire itself. So the biggest concern that we have noticed is that we can notice clear support for historical data, historical spatial data. And such data is key for us because early warning system to a large extent relies on retrospective analysis at some point. We analyze past events like past floodings or maybe simply past sensor spikes. But in order to be able to do this analysis, we need the full context of the event. We need simply weather conditions, for example, at the time. And current services, even if provide some data, they provide only current data. So if we want historical data, we have to manage this data ourselves. Also some thoughts about some conclusions about spatial data, but they are, I think, pretty obvious, which I learned being here on this conference, that this data is not there yet. It was very difficult for us to get hold of data that we need. Like the data about dikes, we had to basically get hold of some PDFs and then digitalize this data from PDFs, for example. And the elevation data is also not there. And even if data is somewhere, it's very difficult to discover. Then a set of comments about services. And by services, I mean here the various applications for analysis on top of spatial data. And there are many applications like this currently existing in universities and in companies. And should we expose these applications, like a flooding simulation, for example, as spatial data services, I think that would be of tremendous benefit. Because then we can build useful applications not only on top of data, but also on top of services that do useful things and can be composed to do even more useful things. But the current state of this is that, of course, these applications are built using proprietary solutions. And it takes quite an effort, engineering effort, or re-engineering effort, to expose these as services. So we can deal with, for example, it seems that simple data formats are preferred like CSV. Also, we deal with tightly coupled situations where we have like computing backend in Fortran and then on top of this Excel spreadsheet, and it's very hard to make a useful networked service out of it. But we also notice that companies, for example, are looking into adopting standards because maybe they see a benefit in it, like there is OpenMI, which is exactly used for plumbing components into pipelines, something like that. Then some conclusions about OGC. Basically, from our point of view, we integrate the services, we build complex systems. And from this point of view, we didn't find OGC very web-friendly. This is rather technical, but I can name a few concerns. Not important maybe for the data providers, or not important for the users, but certainly important for developers of solutions, of IT solutions. So basically, OGC don't use HTTP as application protocol, they only use it as transport protocol. And therefore, all the benefits of HTTP as application protocol are lost. For example, get operation is used for non-idempotent operations, and post is used for idempotent operations, which defeats the purpose, basically, of leveraging the semantics of these operations. And, for example, transparent caching of data retrievals. And I could point out to many such examples. Maybe one more. The hypermedia is not exploited. The hyperlinks, I would be happy to see hyperlinks in OGC representations. Today, for some reason, I have to put together the links myself, like links to a coverage, for example, based on the coverage metadata, which I don't understand the reason. What is the reason for it? As I said, I have a few more comments like this, but maybe we don't have time. And also, finally, some conclusions about technologies. So we were looking, not that we have spent tremendous time for it, but we are looking for some open source solutions that we could use to deploy our services. Very simple setups, research setups, basically. And for the most part, we ended up in implementing our own in-house implementations, with the exception of one coverage WCS service based on GeoServer. But we also were having hard time using GeoServer, and it could not handle all our requirements. For example, we had this requirement of dynamic publishing data, basically updating spatial set on the fly. And in this context, I very much liked what was shown, I think 2 days ago, on the workshop about download services, that currently Atom protocol can be used for download services. I think it's a very good direction, but that's just my personal opinion. Thank you very much.
I would like to thank also Bartosz for his presentation. Are there any questions? Yes, please.
Thanks for your presentation. I'm a graduate student in Istanbul Technical University. My question is, can we reach UrbanFlood's simulation techniques, methodologies, analysis techniques?
Can you what? Sorry.
Can we reach? Can we see?
Well, like yourself, can you open a web page and see the simulation? That's your question. Some
Yes.
of the services are public available, yes. For example, you can access our simple data services. But in order to be able to run the simulation, you need authorization. But if you had this authorization, it would be possible.
Thanks.